Hi, this is Angela Galloway, and I am recording just a quick little video to go over some of the functions that we've been learning to use on our calculator, how to graph, how to find our X and Y intercepts, all those things that we've looked at. And so I just want to go through a few examples and show you with the calculator, how you would be typing those in and how to double check your answers and all that. Okay, so I'm looking at our Math 146 test number 3 review, just kind of to go through some of these examples because this kind of has everything that we've gone over in our Unit 3. So one of the things we discussed was that you can, if you have 2 points, you can put those into your calculator and get the equation of the line, or like in this case, if you just need the slope, it would give you the slope. So to do that, we're going to go up here to Stat and Edit, and that's where we go anytime we want to put in data. So if we have data we want to put in the calculator, we're going to go to Stat and Edit. Now what we're going to do is in list 1 here, we're going to put in our X values. So our X values were -2 and 0. Oh, sorry about that. I put in the wrong negative. -2 there and 0. Then the L2, we're going to put the Y values. So we'll have 5 and 9. So when we're reading these across, that's a point. -2, 5 is 1 point, 0, 9 is another point, and that's what we see here. All right, so once you've typed in the numbers there, it's saved into your calculator. So you just go back to Stat, push Stat again, and now we're going to go over to Calculate. And we're going to go down here to number 4, which is linear regression. Linear regression we're going to cover more in Unit 4, but for now we just are thinking of linear regression as taking those 2 points and finding the line that fits those 2 points. Okay, so we're going to go down to number 4. Okay, and then with linear regression, what they want you to type in here is where your lists are, where your data is, if they're in list 1 and 2 or 3 and 4 or wherever they are. Now ours were in list 1 and 2, so, or at least mine was. So I go up here and push second and 1. And you see in the yellow up here, we have L1, L2, L3. So if you put yours in another list, you just make sure you put it in here correctly, okay? So L1 for our X's, then we do the comma here above the 7, and then L2, and then enter. And then it gives us the equation of our line. It's going to be y equals 2x plus 9. So 2 is our slope, and 9 is our y-intercept. 0, 9 will be our y-intercept, which we already knew from there. So we can use that too there for our slope, or if you calculate the slope, you can go back here and double check, and see if that looks right or not. All right, so moving on, let's see what else we've got here that we can go over. Okay, this here gave us a graph and we're looking for X and Y intercepts, but if we had the equation of a line and we were trying to find the X and Y intercepts, that's something that we could do with our calculator here. So with the calculator, let's say we were doing the equation, let me write it out here, we'll have y equals 2x plus 3. Okay, so since it's in slope-intercept form, we already know, this is our slope and this is our y-intercept. Okay, so 0, 3 will be our y-intercept. So we actually don't have to graph it to find that. We can just see it from there. But we can find it on the graph if we needed to. Remember, when we're going to graph something, we go to y equals. We have to put our equation in slope-intercept form because it's already set up where the y is over here, so we have to put everything else over here on the right. So we're going to put in 2 And then our X variable is this right here. So push that and then plus 3 and graph. Okay, now if you didn't see the graph very well, then you can go to zoom and adjust it. You know, you can zoom in, zoom out. Z standard is typically where I tell students to start because Z standard takes it from -10 to 10 for the X and the Y. So for most of our graphs, that's going to be a fairly good view, but there might be some cases where you have to zoom in a little bit from that or zoom out to get a better view. So like on this one, we could zoom in. Let's try the zoom in here. So now instead of being at -10 and 10, it's going to zoom in and give us a closer look. And so now we can see this X-intercept here, which is what we're wanting to find. We can tell that it doesn't cross exactly at 1 or 2, right, or -1 or -2. It looks like it crosses in the middle. So to find the exact value for that X-intercept, we will go to second and trace, which is our calculate. So pretty much anytime you want to find something on your graph, you can go to the second trace option. All right, and the X-intercept is actually also called the zero of the function because that's where y is equal to 0, so the function is equal to 0 at that point, so that's why it's called the zero. So we hit enter there, and what we need to do is we are telling it where we think the intercept is, so we can give the calculator an idea of where to go. So first it asks for the left bound. So find this cursor and just arrow over until it's to the left. So in this case, that's below your intercept, okay? And then push enter. The right bound, just go up here somewhere to the right. So it doesn't matter how far you go, you know, if you click up here or down here, it's going to be the same answer, okay? So you just need to be to the right of this point and then enter. And then the guess, if you want to, you could go closer to where you think the intercept is, but you don't have to do that. You really can just click enter twice after you do it to the right. It doesn't matter really where you do it, okay? And then we get that the answer is -1.50. So our x-intercept is at -1.5 and 0. Now the way we do that in our equation is we would set y equal to 0, so make this y a 0, and then solve the equation, and you would also get -3/2, which is -1.5. All right, so let's see what else we can do here. Now again, like on this one, once we have the 2 points, we could put those into our calculator and get the slope. We would also be able to get the equation of the line because the calculator gives us that equation of the line using the linear regression. So we could do that part in our calculator. Okay, this one here, when we did our break-even point, so our cost function and our revenue function, you would set up your cost and revenue function, and then we can bring up our calculator here and graph those two things. So I'm going to clear this out, so up there just push clear and then it won't plot that one. We're going to put in 60,000 plus 1.5x and then 21x. Okay, so right now you're not going to see very much on the graph, and that's because our y values are going to be pretty large, right? Because we've got that 60,000 plus something, you know, for our y values. So they're going to be very large. Down here, when we worked it out by hand, we saw that the x value is going to be, you know, around 3,000. So we need to have much bigger x and y values. So what you could do is you could zoom out. You know, you could keep zooming out until you can see the intercept. But the easier thing in this case is probably just to adjust the window to what you want it to be. So go to the window, and now what you're doing is you're telling the calculator exactly what you want to see on the graph. If you don't want any negative y values, then you'll have y start at 0. If you don't want any negative x values, you start x at 0, so you can kind of choose. So in this case, we're talking about cost, so we're just going to start at 0. Okay, and let's say we're going to go up to, for x's, that's our number of books that we're producing. So let's say we just go up to 4,000. The X scale is how many tick marks do you want? Like every mark that's on the graph, do you want that to be a 1, or do you want it to go by 2s or by 10s or 20s? If you have a large number, you probably want it to be not 1. You maybe want it to go by hundreds or 500s or whatever. So in this case here with 4,000, I'm going to let it go by 500, right? So that would mean there's like 8 tick marks on the graph. The Y value, I also want it to start at 0 because that's going to be our money, right? And it's going to go up to, it needs to go up to at least 60,000, right? Because that's where we're starting at, is the initial cost was 60,000. So let's say we go up to 120,000. And this one I'm going to have go by 10,000s. Okay, and that's all we have to do there. And you can change this as needed. So we go back to the graph now and see if it looks a little better. And it does. This is what we want to see. We want to be able to see where it crosses at, right? And that's called our intersection, or in this circumstance, this is our break-even point. So this is the point where before that we're losing money. After that point, we're earning money. So we want to find out, how many books do I need to sell to start making money? Okay, so to break even, how many books do I need to sell? Okay, so just like we did with the X-intercepts, we're going to go back to second trace, which is our calculate, and we're going to go down here to intersect, which is number 5. For this one, because lines, not necessarily these lines, but you could have graphed multiple things at once and they could have, lots of different intersection points. We need to tell our calculator, which lines to look at. Okay, so the first curve, for us, that just means what's the first line. Okay, so we're going to click enter here. You see it's on this line up here, so we're going to click enter. And then the second curve, it automatically went to the other line, and it's usually going to do that. So the only issue is when you maybe have multiple lines in there and you're trying to pick between different ones. But for our circumstances, we're usually just going to have 2 lines in there, so it won't be a big deal. So we'll push enter on the second curve. And then for the guess, again, you could go a little closer to where you think it is, or you can just push enter again, and that'll be fine. All right, so it says our intersection right here, and remember we want to know the X value because that's telling us how many books we have to make in this case. And it's 3,076.9, which we said we would round up to 3,077. And that's exactly what we got when we worked it out by hand too. So this is nice to have, if you have time on the test, in class, you could, use this to double check your answer. But especially on your MyLabs, you can use this, as you're working out problems to maybe double check some, or after you've done several by hand, maybe you just want to do some on the calculator and see if you can solve them that way as well. Okay? Okay, so with logarithms, quickly, just as a reminder, um, our logarithms, let me get out of this. Remember to get out of your graph, you can just do second and quit there and it'll take you off of that screen. So the buttons we're typically using with our logarithms and exponentials is this ln key, which also has the second function of e to the x. So for this example here where I was taking the natural log of both sides, I was left with x equals natural log of 24. So I'll click the natural log. It automatically comes up with a parenthesis. So I'm going to put in 24 and then close the parenthesis and then hit enter, and then I'll get my answer there. If I'm doing something like this one down here, where I'm doing the natural log of 100, then dividing by 4, I want to make sure that when I do the natural log of 100, that I close this here and then divide by 4. Okay, if I don't do that, this is what's going to happen. Okay, see, we got two different answers, right? That's because this equation that I typed in says take the natural log of 100 and then divide by 4. This, because I didn't close my parenthesis, says take the natural log of 100 divided by 4. Okay, so those are two different things mathematically. It's going to come out to different answers. So you want to make sure that you close the parenthesis correctly, where you need it to be closed. In this example here, which is what a lot of our growth and decay functions are going to look like when we're trying to solve them, we're going to do the natural log of 100 divided by 421. So we do want all of that in the natural log. Okay, and then, so that's closed this part out. Then we're going to divide by whatever's in the denominator. So the negative 0.013. And then we get that 110.6. Okay, so you just want to be careful about closing that parenthesis. Um, the same thing with our exponentials. When you click the e to the power of, it automatically comes out with a parenthesis there. So, like in this case here, let me go back and put in, we were wanting to do 421 times e to the negative 0.013 times 60. Okay, so the 60 we want to be in the exponent, so we need to include it inside the parenthesis. Okay, if we were to do it the other way, where maybe we, closed it here or, did something else, then we're going to get a totally different answer, right? Because now it's only raising this to the power of that and then multiplying the whole thing times 60. So, you're getting a totally different answer, right? So make sure you close the parentheses correctly. That's a big deal in a lot of these problems with our logarithms and exponentials. All right, so that was just kind of a quick tutorial of some of the things we went through on our calculator. Anytime you want a graph, you go to the y equals, and then you go to the graph to see what the graph actually looks like. If you want to see what the actual point values are, you just go to second graph, which is the table, and that's going to give you what all the y values are for your x's. Okay, so like, when it says plug in a 2 for x or whatever, you could say, well, that's going to give me a 42 or, whatever your equation is in there. And this one has two y's because we are graphing two y's at that point. But usually we're just, looking at one at a time. All right, so hopefully that was helpful and this will help you to check your answers on your homework or to check them on your test that's coming up. If you have any questions, please email me at angela.galloway@kctcs.edu.